Welcome. So the session you actually wanted is down the hall. I'll give everybody a moment. Okay. I got it. Oh, my phone's over there. I was going to take a picture, but because no one will believe that people showed up. Anyway, so all seriousness, my name is Mike Coleman. I do tweet at Mike G. Coleman. Who am I? So my first half of my career, I actually was a SYSADMIN. I worked on networking predominantly, but also servers. I did this at Intel and HP, so pretty big enterprises at the time. I was a certified Banyan engineer. I paused there for the chuckles, and I always get them. I was a Microsoft certified systems engineer on Windows NT 3.1. So this gives you an idea of how long ago that was, right? So I moved from there, and I've done product management and technical marketing and evangelism for most recently Puppet, before coming to Docker about 2 years ago. VMware before that, so 6 years in virtualization, and before that, about 6 years at Microsoft doing IT pro stuff on the first version of Windows I shipped was Windows 2000. And then I shipped Windows XP, and then they said, stick around for Vista, and I said, nah, I'm going to die growing old if I do that. So I moved on. I'm an IT pro. I'm not a developer. And I don't think I pretend to be a developer in any of the demos I do today, but sometimes I do pretend to be a developer. I am not a developer. It's more of an IT pro. You can follow me on Twitter. I encourage you to do so, especially if you're a fan of soccer. If you're not a fan of soccer, 37% of the time you'll get work-related tweets. So maybe the ratio is right for you. So before we get started, I know that the title indicated this was for sysadmins, but I'm curious about who everybody in the room is. So just starting over here, if you could just introduce yourself. No, let's do it. Okay. How about this? If you are a developer, raise your hand. All right. If you're a sysadmin, raise your hand. Nice. If you're a manager of either of those groups, raise your hand. Nice. Okay. I'll try to talk really slowly. Okay. So, and then, I know it's DockerCon, but this is I still like to do this. So we're going to go on a scale of 4 to 1. How many of you are running containers in production today in your environment? So that's 4. Okay, 5 or 6%. How many of you have a POC going where you've sort of concocted up your own Docker files and you're using, you're kind of at that level? How many of you have grabbed an example off the internet and you've stood up WordPress or you've stood up a MySQL database? How many of you are that? I call that like a 2. And how many of you have done Docker run hello world or something, or know what Docker is? Okay, perfect. That's a good split. And that's pretty much, I was just having a conversation with one of my coworkers about, this idea that when you work in the project every day, you think about that people know more than they do. And that's just the way it is in everything, right? One of the quotes I remember from Microsoft when we were shipping software was, you are not your customer. Right? And so it's good to see new people coming out at DockerCon every year and continuing to, grow the community. So we're going to start off by talking about what Docker is not. Docker is not a VM, right? And I do this because it frames the discussion for everything else. And most of you are probably like, I know it's not a VM. But for a lot of people, this is an easy connection to make. And I hear it all the time, even now. I hear people say, oh, hey, containers, man, they're just lightweight virtualization. It's just a lightweight VM. It's an easy connection to make, right? Both of them offer this atomic unit of compute, right? You have this thing that does work that you can move around. That's what a VM is. That's what a container is. But their architectures are completely different. And their use cases are completely different, really, at the core. And so how do you compare and contrast them? So if you have to go back and explain to somebody what's a container versus a virtual machine, this is an analogy that I've used now for a little over a year that seems to work for a lot of people. Virtual machines are houses. So what makes a house? What's a house? A house is this fully self-contained unit, right? A house has its own plumbing, its own heating, its own air conditioning. If I need another house, I dig another foundation, I've put up some walls, and I get a full house with its own plumbing, its own heating, and its own air conditioning. If I'm running a virtual machine, and I've got a web front end, and I need to horizontally scale, I stand up a complete instance of the operating system. I dedicate these resources to that piece of work, right? And it stands by itself. Even though they're pretty much 90% the same, 95% the same. The reason technologies like memory deduplication work so well with VMs is because basically a lot of it's read-only that's exactly the same. But we still stand up two distinct components. So houses, the other thing about a house is that they only get so small. Now, I'm not talking about container houses in your backyard because that breaks my analogy. We're talking about are like, proper houses, right? So the first house I bought, 2 bedrooms, 1 bath, a living room, and a kitchen. And it was about 800 square feet, about the smallest house I can find. Smallest VM you're gonna run, a gig, a few hundred megabytes maybe. VMs are considerably larger. They take longer to boot up as well because they're booting a full operating system. They take 5, 10, 15 minutes to boot depending on what you're doing, right? Sometimes a little faster, sometimes a little longer. Containers are apartments. They're apartments in an apartment building. What differentiates an apartment from a house? Well, one, apartments share a whole bunch of infrastructure, right? They share heating, plumbing, air conditioning. They share an elevator, right? Apartments come in a lot of different sizes. My son Corbin is in the room here somewhere. I saw him walk in. He's back over there in the corner raising his hand. Corbin he has his first apartment. He's moved to San Francisco and he's going to software school down there, and his apartment is a bunk bed in a 1-room studio with 3 other dudes, right? Like, that's an apartment, right? We call that the Alpine Linux apartment, right? Then you can have a Windows Server Core apartment too, right? Which is like, 10 gigs, and it's like a penthouse somewhere. So apartments vary greatly in size depending on the needs of the person staying there, right? The most important thing to a college student is probably cost. So what do you get? That's what you optimize for, right? So that's some of the things. So how does that relate to containers? Containers live in an apartment building that we call a Docker host. It's any server that runs the Docker engine, which is like the doorman. It starts and stops containers. It runs them. It does not interrupt them. It does not interject itself between the execution of the application and the hardware like a VM does with a hypervisor. It just starts and stops them. They share a kernel, right? They share the kernel. Unlike a VM, they are not monolithic and they don't stand alone. Every container is going to share that kernel with every other container in there. Now, they are isolated though. They have a front door just like a house. You can't just walk into somebody's apartment, right? Got to go through that front door just like this. So you got that isolation component. But because they are smaller and they share the operating system, they boot up in about 3/8 of a second. And they can be as small as, there was a contest on Twitter to write the very smallest hello world container you could write. And it was like 60 kilobits or something that somebody wrote a container that would start up, print hello world, and exit, right? And so pretty small, really hard to do that in a VM. So, and now that all of you, that's all, now I've finished telling you everything you know, that you already know. Well, maybe not, but mostly so. So, just because they're different doesn't mean they're mutually exclusive. So, that question that I just answered was one that I get all the time is, well, what's the difference between a container and a VM? Why do I care, right? Then the next question is, well, where do I run my applications? A container or a VM? Where do I put them? Where do they go? What do I do with them? The answer is, what makes the most sense, right? So the subtitle for this presentation is, I'm going to give you the questions that you need to answer in order for me to answer the question that you want me to answer but can't answer for you, right? And this is one of those questions, where should I run my application? Well, I don't know what your application is. I don't know what your requirements are. What do you value? Are you the college student in San Francisco where the most important thing is price? Or are you somebody who's later in life and made a little bit of money and the most important thing to them is they want to live at the beach? On the beach. Those are vastly different priorities, right? Applications have vastly different requirements depending on who you are. So you can absolutely run, on your left, my right, the example of bare metal, right? So containers firing up on bare metal. Why would you do that? A lot of reasons you do that, and we're going to talk a little bit more in detail, but the big one here is performance, right? If the most important thing to you is performance, then you're probably going to go this route because that is almost always, nearly always, I just hate absolutes, or I would say always, faster, right? But what's the limitation there? Well, why did virtualization, so now this is audience participation time. Why did virtualization gain popularity in the first wave of virtualization? Density, right? And that's why you wouldn't do that, right? You wouldn't do that because that's $1 million box and I can only drive it at 30% and I don't want to throw away $700,000 in compute capacity, right? So you do what you do on the other side, right? Where you say, all right, well, here's a bunch of VMs and now I can drive the capacity. The other thing is, it's sort of capacity related, but if these machines over here aren't all the same operating system, right? They're not all Windows or all Linux. If you have to mix and match the OS, you have to go with a virtualization strategy, or you have to go with 2 servers, right? You can't put them all on the same host. So what you get over there, you got a Docker engine, it's Windows, couple apps running, got Linux, got an app running, and then you got some traditional VM over there. You do that for a number of reasons, right? Existing skill sets, right? Security. There's organizations that have requirements that say you cannot share a kernel. My application cannot share a kernel with any other application on this system. Virtualization allows them to put multiple machines on that server and stay within the realm of that requirement. That's why today, there was a lot of cool stuff. How many went to the keynote this morning? So my favorite announcement, the one that got me the most jazzed, was Hyper-V isolation for Linux containers. I'm just going to talk about it. So Hyper-V isolation, what it does is it's on Windows containers today. It actually boots the container up in this mini VM automatically. So you get the VM isolation, right? But you don't have to stand up a VM. You literally say docker run -- isolation mode or -- isolation equals Hyper-V. It's this automatic thing that gives you this shielding. So you could do a bare metal instantiation and still have that isolation that you require. It was only on Windows containers before, now it's on Linux containers, or it's going to be on Linux containers. That's a really big deal if you have compliance concerns. And you should definitely track that, especially if you're a shop that runs predominantly Windows with a little bit of Linux and you want to run those Linux containers on a Windows box. So definitely track that. It's super lightweight. So the question was, how lightweight is that shell, that Hyper-V, that shell? It's basically, when you boot the 2 containers, they boot up, I think one without Hyper-V isolation boots up in a second, and one with Hyper-V isolation boots up in 2 seconds, right? I mean, it's not orders of magnitude, it's just fractionally more. I mean, it's twice as much, but we're talking 1 second versus 2 seconds, which is really nothing. So you're here because you're interested in containers. You're here because you want some guidance on what do you do? What are the things that you need to ask? What are the questions you need to answer for this, for this to happen, for this to make this transition? And I'm going to break it down into what ends up being 3 buckets, but performance, scalability, and costs. Those things are directly related. Right? If I have better performance, I typically have better scalability. If I have better scalability, I have reduced costs, right? So if that's the most important thing for you, that'll be, what we talk about there will be the most important. Other people are more concerned about security, right? How do I secure this? And this falls into the camp of you don't want to think about containers as VMs. You don't want to go into this and say, today I do this with a container, so I'm going to do this rewind. Today I do this with a VM, I'm going to do the same thing with a container. It doesn't make any sense in most cases, right? So we'll talk about specifically around security, a couple things that are very unique to containers that you'll want to think about as you look at your build, ship, run pipeline. How do you take things to production, and how can you protect your information assets more completely than you can with VMs today in a lot of cases. And then we're going to talk a little bit about existing skill sets. How many of you are a VMware shop today? And how many of you are an AWS shop today? Right, Azure? Right, so a lot of different tools, right? VMware is almost universal. You almost don't even ask that question anymore. It's just there, So we're going to start with that whole discussion about performance, scalability, and costs, and how you should look at that. So we did a test. So I was on the team that did this, and as was an industry consultant who's actually speaking at DockerCon. His name is Brett Fisher. Brett's a super smart guy. He's doing a talk similar to this one. So here's how I position this talk. This is the generic version of a lot of really great talks by customers where they're going to get into very specific examples of what I'm telling you generally. So I'm saying generally you want to make a decision about bare metal versus VMs. You're going to go into a talk and they're going to say, I went with bare metal because for my application, it looked like this and this is what I cared about. Right? And when you find that customer that you match up with, then you have your answer. Right? So that's sort of if you attend my session and there's a call to action at the end, you definitely want to be on the lookout for sessions from Intuit, ADP, Visa. There's one more, but it's on my last slide. Anyway, so Brett is giving a talk as well. Good guy. HPE is on the show floor. Basically, what we did is we went and we took Docker CS Engine 112. So we did this at the end of last year. We took ESXi6, SysBench as a benchmark, and we ran everything on RHEL 7.2 and using the Docker engine, not the RHEL fork, but the Docker engine. And we ran on DL360s with 3-par storage, right? So pretty mainstream, compute platform that you'd have. And here's what we figured out. If you look at it, and what we did is we said, okay, let's first look at just reducing the number of virtual machines. And the idea, what we're holding constant here is the amount of the size of the virtual machine, right? And what we're measuring is how much work can we do? How much would SysBench, what would they measure in terms of work? So we started up here on your left, my right, with 8 VMs. And we had SysBench running in each of those, and we cranked away, and I don't remember the exact numbers, but let's say that each one of those VMs did 1,000 TPMs, whatever the measurement was. So you had 8,000 total TPMs, right? 8 VMs, each at 1,000, 8,000 total. So then we said, let's just reduce the number of VMs to 1. So we said, if this was 2 cores and 8 gigs of RAM, let's do 16 cores and 32 gigs of RAM, right? So 1 VM that equaled the same size as the 8. So we're still using the same amount of virtual compute resources. But what we found is that you could get about 25%, you could get about 27, 28% more work done. Essentially, if you had a server form of 4 servers doing that work, so 32,000 TPMs, you could get 32,000 TPMs out of 3 servers. You could take a server completely out of the mix by moving to a single virtual machine. That's what I meant by saying, look, it's almost always going to be better. We haven't talked about bare metal, right? But this idea of consolidating down, containers are almost always going to be faster. The other thing is that because of the container architecture and the way we share the disk images and the way we share some memory, we actually use 35% less storage, 30 to 35% less storage, and 7% less RAM. But, 2 seconds. But, you'll also notice we went from managing 8 guest operating systems to managing 1, right? You had 8 VMs you had to patch before, now you have 1, right? You had 4 hypervisor licenses you had to buy before, now you have 3, right? So if that works for you, it could be some savings, potentially, right? Back here, sorry, thank you for your patience, appreciate it.
Let's do the questions at the end of the talk.
Okay, yeah, maybe write it down or something. Yep.
Yeah, it's the general thing, yeah.
Okay, he's the boss, I'm just the talent, and shaky at that. Okay, so we took that exact same thing and we moved it from the 8 VMs, right? So the 8,000 TPUs or TPMs, and we moved it to bare metal, 8 containers running on bare metal. Those 8 containers were basically able to do almost twice as much work. You got almost a doubling of output by moving same hardware, just going from containers to bare metal, right? So if you care about performance and you're getting the right load on the server and you have a system to let you provision bare metal effectively and you want to run your own data center and you see all the ands, like this doesn't mean this is what you want to do. This just means this is something you should think about in the context of everything else you need to think about because you don't have enough to think about, right? 30% less storage, less RAM. In this case, we go from we get no hypervisor in this case, right? And we go to native host OS, Docker engine, right? So you're running something on there, some Linux variant or Windows Server 2016, containers right on top of that. You're patching the native host OS and your containers, of course. And reduced data center. So there's a whole bunch of soft costs in there. But what we found, and this study, and I changed the slides at the end. Oh no, it's there. It's on the next slide. I will tweet my slides out after this talk, so you'll be able to get them, and I will put them in the DockerCon Slack channel as well. So after my talk, as soon as I'm done here, I'll go upload them somewhere. I'll put them in PDF. I'll upload them onto Google Drive or something, and then share the link there so you can have the link to the white paper because it's on the next slide. So there's a whole bunch of advantages there, right? I will say though, that this happened not automatically. So we ended up doing some CPU pinning, right, to maximize it. So we tuned it. We didn't just take the workload and dump it, right? We had to look at it. We had to analyze it. And this is a quote that if you heard me talk about this topic before, I often say, just because you put your workload in a container does not abdicate you from the responsibility of understanding how your application performs. You have to know that, right? And so we knew that, and we did some adjustments. I will also say this is pretty much a worst case scenario for us because the number one resource in this was CPU. Suspension would just take all the CPU it could get. So it was a CPU bottleneck, and that's kind of a worst case. This is sort of like the marketing summary slide, but at least it's got the value add for you guys is right here. This is where you can get the paper. And I don't expect you to like write that down because that's like the most ridiculous URL ever. But check the DockerCon Slack or my Twitter and you can get the slides and find it. Or you can Google HPE Docker containers VMs and it'll show up. And you'll also find the initial version of this paper which did some similar testing using a bunch of other benchmarks in different scenarios that show you performance increases across the board moving from containers to VMs to containers. So if you care about performance, if that is your number one thing, right, good, but plan for higher density. Plan for more containers than you had for VMs, right? Or put it on, if you're going to go on bare metal or bigger VMs, right? You're going to have some changes here. You're going to have to be flexible. You're going to have to do some testing and you're going to have to kind of work those things out, right? But none of it's going to come for free. There's work involved in all of it. Okay, so container security. I have a lot of people ask me and they say, is a container as secure as a VM? Like, yeah, I think it is, but that's the wrong, I shouldn't say it's the wrong question. That's just one question. Isolation is not the be all end all of security, right? If I asked you today, how do you know that VM that you just put into production is what you think it is? How do you know that the golden image that's named appropriately is what it purports to be? How do you know that I didn't go in there and change something? Right? How do you know that when you provide a golden image of Windows Server 2016 and you hand it to a team to build that out into an application, that they're the ones who did it? And how do you know the vulnerabilities that may be introduced into that image after it goes online? Not day 0, but day 1 or 2 or 30. The most common exploits are going to be those for unpatched vulnerabilities that have been known about for a long time. It's not 0 day. It's not keeping up on our patch records, right? So are your images up to date, right? How many of you put passwords in environment variables? How many of you put them in scripts? See, no one's going to raise their hand, but you do it. Like, I know, I did it. You do because your boss is sitting next to you. Well, we'd never do that. That's not secure. We use, we have a system in place for that, sir. And then at the end of the day, are your communication channels secure? Are you communicating over TLS? Do you have certificates in place? How do you rotate them out? Right? If you were in the keynote, this seems very familiar. I assure you, I wrote this slide before the keynote. I saw Diogo in the hallway. I'm like, bro, I totally cribbed your whole presentation, right? Your whole segment, my thing. He was happy about that. So we think about security in terms of usable security. If it's not usable, what do? You write the password on a Post-it note and you stick it to the monitor because I don't want a 15-character password that has to have 4 special characters, an uppercase and a lowercase letter, cannot repeat my name, cannot have the word password, cannot have any word in the dictionary. I don't want that, right? So I stick it on a sticky note. If it's not usable, they won't use it. It's the idea that everything that you need for your application, from the inception of that application to the time that it hits your server and is running in your environment, that you know the provenance of that application and the state of that application as it relates to security. Have I been exposed to a vulnerability? And then it works. It doesn't matter where I put it, right? It doesn't matter if I'm running on AWS or Azure or vSphere or bare metal or my MacBook or your Windows laptop or your Surface Book or we don't run on iPads, but so much for the mobile revolution. So this is stuff that, everything I've talked about, sort of generic, this is a commercial product, right? So we do have commercial products. We sell something called Docker Data Center. You can demo it down on the show floor. The Docker Data Center offers you things that, like application secrets that you saw this morning, being able to securely lock down sensitive information and pass it across your network over a TLS link, TLS encrypted link, right? But keeping a workflow that lets operators and developers do their jobs and reduces that friction, what Solomon talked about this morning. Making sure that if something hits the disk, if a secret hits the disk, it's encrypted. Right? And all of this happens by default. And all of this happens literally with a 3-word command: Docker, swarm, init. When you type those 3 words on a Docker daemon, you get TLS, you get secrets, you get all this stuff. Because it's easy to implement. And then if you need to change it, if you need to modify it, if you say, well, you know what? I like Vault by HashiCorp. Groovy, I'm happy for you. Then you can use that instead of our secrets management. Well, you know, I have my own PKI set up and I want to do my own certificate authority. Great, do that, right? But we're going to make sure but when you start in the right place. And we're going to do it in a way that doesn't impede you, right? So then when you get it in there, we have users and RBAC, role-based access control, right? And we'll run that on any platform you want. So I'm going to do a demo now. And I do not have a cowboy hat and I do not have a cow skull. I'm a little bit worried at this point. I'm worried because, okay, so, hey, I have this application here. Let me do this. I have this application running down here, and it's my 1.0 version of my docker.pets application. And you can see here, we're using Docker Trusted Registry, which is a part of Universal Control Plane, which is part of Docker EE Advanced, which ships alongside Universal Control Plane. Someone's got to clean that mess up. But I'll leave that to the marketing people, even though I work for the marketing person. What we see is we're using a feature called Docker Security Scanning, and if I click on this image over here and I view the details, I can see that I have vulnerabilities. Well, in this layer, I've got a vulnerability with Mussel, and then I think the other one is in curl. Well, let's see if we can find it. Nope, it's not there. Yeah, so it's over here. It's when it's installing Python, or it might actually be in curl. It might be in that curl command, I think is what the guy told me. But so we've got a bunch of problems. And let me tell you something about this application. This is a true story. I'm not making this up for the demo. When I put this together a week ago, there was only one vulnerability that was known. In the ensuing week, additional vulnerabilities were discovered, right? So we load a CVE database up into DTR that gets updated regularly, automatically if you want it to be. And as these vulnerabilities are discovered, you get the notification. So how am I going to fix this? Well, I'm going to come over here to my trusty iTerm, and my trusty bash shell, and I'm going to clear this. And I'm going to I've got, and I'm kind of doing this backwards. The original, I should have actually left the Docker file in its original state. The original Docker image was based on Alpine 3.3, and that's where those vulnerabilities came from, right? So I'm gonna run it with Alpine 3.5, right? So I'm updating the base image from 3.3 to 3.5, and 3.5 is clean. It doesn't have those vulnerabilities. So I do a Docker build. I'm so lazy, hold on. I'm so lazy I don't even use the new commands. I know. It's going to bite me in the keister one of these days. So I just told Docker to build me a new version of the application using the updated Alpine image. And so it's going to go off and do that. This is going to take a couple minutes for it to do that. And then what we'll do is we'll push that up to the registry, and the registry will start scanning. And when that happens, I'm going to go ahead and I'm going to continue talking. We'll come back to that in a minute. But let me just start that Docker push. For those of you who are newer to Docker, what I did was, on that first command, I said, build me a new Docker image, name it the same thing as the image that you just looked at, but make it version 2.0. So that's what the build command does. The dot at the end of the build command says, build it from that Docker file that I just showed you, and then this command says, go put that up on that registry for me. Go put that on Docker Trusted Registry. So, all right, so it's going to do that, and the scan takes a few minutes, so let's go ahead and go back to the slides while we can, and carry on to the next bit because I want to have some time for questions. So leveraging existing skill sets, what does that mean? It means I think you need to meet the teams where they live, right? Meet your developers where they live. Meet your operators where they live. If you are a vSphere admin, and you use vSphere every day, and that's where you want to operate your Docker containers, that's great. If that is you and you're interested, and we'd love to talk to you a little bit more about how you use vSphere and containers. We have a couple of focus groups we're doing. We're looking for a few people to do that. So if you'd like to be part of that effort here at DockerCon, come see me afterwards, and we'll give you the details on that. That's just a little thing there. But if you're a developer and you want to use a Macintosh, then we have Docker for Mac. If you want to use Windows, we have Docker for Windows. If you are a Linux guy or gal, just put it on Linux. Run the engine there, right? Where you work shouldn't change. Your IDE shouldn't change, right? If you're ops and you're in the cloud, now the VMware stuff, like we're still sorting out, but for cloud users, we have AWS and Azure on lock, right? We have ways to stand up, we have ways of standing up Docker Swarm clusters really easy in these cloud providers and then using their tools to monitor those things and to scale them, right? So if you're an AWS administrator, we've got a tool to help you do that. So let's take a look at that tool actually while we're sitting here. So let me get out of this. Uh-oh, what happened? Oh, wow, that's weird. It's so weird. It's like I can't see it. No, I don't want to see what 729 possibilities of what? All right, I'm literally, because like it's got PowerPoint on my screen here and like it's up there, it's totally different. So, dun 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 dun. I'm up on AWS, but that's not where I wanted to start actually. I want to start here, and I want to start up in Docker Store. So if I go to Docker Store and I say get started with Docker, and I want Docker CE, I can come down here and I can get this Docker Community Edition for AWS. And this will take me into the AWS console. And using this CloudFormation template, I can specify everything about my Docker swarm, right? So this will build me a Docker swarm in the region I want it to, with the instance sizes that I want, with the number of managers and workers that I want, with using the SSH key that I want, right? So I specify all these things. I can choose to integrate with CloudWatch, so all my logs can go into CloudWatch, right? And if I click create, then it goes off and does that. And what you end up with is a Docker swarm running up in, well, it's right there, you can actually see it. Let me just clear it and make it a little easier to see. Boy, this over-the-shoulder thing is not easy, let me tell you. So that's my swarm. So I built a one manager, 3 worker swarm cluster up in AWS. So if I go back over to Windows, no, not that. If I go back over to this, let me see something real quick here. If I do this, and I do this, oh yeah. So I end up with this stack over here, right? And so the thing is, we don't just throw up 3 VMs with Docker running in them. We build you a swarm cluster that has a load balancer in front of it, that has a lockdown firewall, right? That has security around it. When you deploy a new application, we look at that application, what ports it's using, we open the firewall rules appropriately for your load balancer. Right? So it stays that way. You can see everything that we create here in the resources, and then you can see the outputs here. And there's a couple things that are important. This is where you find your applications, right? This is the load balancer that gets updated when you stand up a new app, right? The name isn't important, but we give you a load balancer, and then we also give you access to all the managers, so you can SSH into them and manage them manually if you want. That's what I just did, right? I SSH'd into that manager using that was on this list. We deploy those resources, those managers and those workers in auto-scaling groups, right? So if I come over here, I'm gonna just do this, I'm gonna speed this up a little bit because I wanna go a little bit faster. I come over here, the node auto-scaling group, I have 3 nodes. Remember, that's what it showed. If I wanted more, I would just come in here and edit it, and I would increase it. You want to put some rules around that? Knock yourself out. As soon as those nodes come up, they'll join the swarm cluster, right? So I'm running some applications. All my logs end up over here in CloudWatch. This is the log for my Redis container that I'm running. It's mapped here to CloudWatch. So if I'm an AWS person, I've got access to AWS tools that help me manage my Docker swarm. This is similar to what ECS offers or ACS offers, right? Same sort of idea. So let's go back while we're here and come back to the trusted registry, and let's go back up to repositories, and let's see what happened with this. Boom, clean, right? So that was the update. Right, so what you would do from here on out, you would just go to the Docker, you would go to your universal control plane, you would say update the service with version 2.0 of the application. You could set a rollback policy that says if this fails, stop, and you could start rolling out the upgrade to all of those effective machines with one click, and you would update all of those images that were in production. And you could do that in sort of a blue-green way, and the load balancer would help you out. All right, let's jet back over here into the slides. We've got about 10 minutes. Okay, we're good. I want to save about 10 minutes for questions, but it would be a little bit less than that.
5 minutes.
Look, man. These good people want 10 minutes. All right, we're going to be fast. And I'll stick around for questions as long as because we have a break after this, so I can stick around and answer questions. All right, so real fast. So you say, okay, I'm down. Like, what do I do with my applications? There are many, many ways to deploy your applications. And you're going to hear a lot tomorrow about something called migrating traditional applications, right? That is saying I've got an application that's a .NET application or a monolithic application in a VM today, and I want to put that thing in a container. How do I do that? Outside the scope of this talk, but there are talks on that. If you go down to the hands-on labs, there are 2 different labs on how to do that for .NET applications, one for developers, one for operators. If you are lucky enough, right, so maybe you do that traditional app. Maybe you then take that app and you say, I'm going to start breaking that apart. I'm going to start pulling that into microservices, right? I'm going to put it in a container, but I'm going to pull out the auth service, and then I'm going to pull out the catalog lookup service, and I'm going to pull out the message queue. And you can start deconstructing that. Monolithic applications can talk to containers. They can talk to applications running in VMs. It doesn't matter. Those things can interact. If you're lucky enough to be in a greenfield situation, that's great too. The talk, I think it's by Northern Trust, is all about how they did a greenfield application in 5 months in a company that's 100 years old with many thousands of employees. It's a really good talk. So some learning. So these, like I said, this is the generic version. If you do not have time for those customer talks, I've got 2 more slides that tell you what I learned by listening to all of them. 1, you have got to, from the cultural side, you have to involve all the people. From the beginning, you need all the people in the room. You need your devs, you need your operations people, you need your security people in a big way. Right? You need executive sponsorship because there are going to be times where people don't want to listen to you. They don't want to move forward on this change because it is painful. It's not easy. If it was easy, we'd be at 15,000 people instead of 5,500, right? And performance people, right? All the people that go in and have to touch that container. You need them in the room. Choose a good partner. If you are able, right? Someone like, we have like partnerships with Avanade, we have partnerships with IBM, HPE, not HP Enterprise, HPE, right? We have a bunch of local regional partners. Find somebody who has helped people down this road. There's a lot of people that have done it. You want a strong partner in your corner when you go to make that thing because you want that first thing to be successful. Define your guardrails. What are you going to touch and what are you not going to touch? Leave the database in the VM. Leave it there because that's tricky, right? Take the web app first. Leave the database alone, right? You're going to make mistakes and you're going to be flexible. Flexible. That's a new word. So you're going to have to be able to deal with, and you're going to have to be an agent of change, right? If you're leading this initiative, you're going to have to pick up that mantle and be an agent of change. And you're going to have to wake up some days and go, that was completely wrong. Or you know what, we thought that the CISO would let us do this thing and he's not going to let us do it, so we've got to backtrack a little bit. And sweat the small stuff. Document everything. Use labels profusely. Label everything. You may not even know when you need those labels. Labels can be affixed to containers and engines to describe things about that container, and they're completely arbitrary. You could have a label that says this runs on SSD in the Northeast region on Amazon and was installed by Mike. Right? And that may come in handy because you may have an application where SSD is super important. You've labeled all the machines that have SSD. It's super easy to deploy it onto those machines because you took the time to label them. Label everything. Sweat the small details. pick the right project. You've got to start small. Don't try to boil the ocean. Some people do, but get a win under your belt, right? It doesn't matter if it's greenfield or microservices or next gen 12-factor cloud native, whatever you want to call it, right? Pick an app that makes sense for you, but know why you're picking it. Like, why are you doing this application? Why does this application matter? Make sure you have a plan for things that can trip people up, like static port mappings, right? How do you deal with static port mappings in a world where the Docker host can only expose port 80 one time, right? It can only expose port 3000 one time. What are you going to do about that if your application is hardwired? And they conflict. How are you going to handle that? Moving your container through different environments with different config settings. How are you going to handle that? What are you going to do about that database? What are you going to do about that persistent data? All these problems can be solved. Just think about them. Right? Go into it with thinking about that ahead of time. And then I talked about this, but adopt your processes to this brave new world. You don't treat the VM like you treat the container. You don't patch a running container, right? You patch the underlying image and redeploy it. You don't back up the running container. I mean, you can, but think about these are different things. There's things that you configured before. You can't just go, oh, it was running over here with a heap size of 1024, 6, blah, blah, blah. I'm just going to put it over here with a heap size, because it may not work, right? It may not be the most optimal thing. So don't just think it's like this. We talk about lift and shift. It's more like lift, tweak, tune, fight, cry, sweat, and shift. All right, so that is the end of my talk. I'm 1 minute over. I appreciate that. 2 slides, please bear with me. What to do next? Go to the hands-on lab and try the tech, especially if you're new. We've got a bunch of labs down there, 8 or 9 of them for you to try. There are some amazing customer sessions where they will talk about stuff that I've talked about in very, in detail about how these sort of principles and guidance applied to them in real life. Pick a pilot project, get your hands dirty. Maybe just do it as a skunkworks thing, not for production, but get your hands dirty. And then please share your knowledge. We're all early in this journey. So what you learn here, come back next year, do a talk, share it with us, tweet about it, write a blog, like whatever it is. Like go to your local Docker meetup and share your story and help everybody else in the community learn from you. Follow us at Docker, tweet at DockerCon, and you can follow me at Mike G. Coleman, 37% work, 63% soccer. On your app, you have the ability to rate the session. I value your feedback. Even if you didn't like it, I value your feedback. You can get that by finding the app. In the bottom corner, this is like a thumbs up. On mine, it was like a little survey thing. Click that, you can rate it, and you can give me your feedback. With that, thank you so much for attending DockerCon. Your support is humbling. If you are interested in the vSphere stuff, is that what you want me to say? If you're interested in the vSphere stuff and giving us some feedback on how you want to use containers on a vSphere platform, come over to the front and talk to me or Jenny, and we'll hook you up with that. With that, I can take questions.
Let's take maybe 3 questions.
Who's got a question? Anybody? Perfect presentation, no questions.